So this is an experiment where we want to verify the Bernoulli's theorem, right? It's a Bernoulli's theorem apparatus. So you would have studied in your fluid mechanics, so that the Bernoulli's theorem states that the total energy of the flowing liquid is constant. The energy is constant as it flow through a variable cross section, right? So provided that so there is no addition and deletion of any energy. So the total energy is constant. So this is what you're going to verify this, right? So I have a cross section region where in which we observe variation in the areas, right? And at different points in the flow section, I have the piezometers are connected, so that the pressure head available at these various points are directly obtained from the piezometers. So here there is a pump which is used to circulate the water, right? So there is a overhead tank, right? So the pump pumps the water to the overhead tank, and then again it flows back. It is a closed system, right? So this you are required to do at different flow rates. So the flow rates can be set with the help by operating this valve. So to start the experiment, you have to switch on the pump, right? Set the valve at a particular position. By that you are setting the flow rate, right? So once that flow rate is set, then you are just measuring the piezometer readings at different locations, right? So suppose you are asked to do the experiment at 3 or 4 different flow rates, right? So keep a minimum flow rate. So then you go on closing that, so that between the minimum and maximum you have some 4 flow rates, right? So each and every flow rate, just wait for some time, and then once the values in the piezometers become steady, then note down these values. And if you want to measure the flow rate, so there is a measuring tank is available with the scale for indicating the level of water inside. So you just, with the help of the stopwatch, you just make it like this, so that the water flows directly into the storage tank. Just note down what is the time taken for, let us say, 10 centimeter rise or 20 centimeter rise. So with the help of that, you will be able to find out what is the flow rate, right? So the same the procedure you have to repeat for the 3 or 4 different flow rates, right? Then each and every flow rate you need to find out the piezometer readings, right? So then with the help of the readings, finally you are required to do a graph by showing the length or the cross sections at the x-axis and the total energy. The total energy is as you know, that summation of the pressure energy, velocity energy, and the potential energy, right? So the potential energy, if the entire cross section is at the same level, so the potential energy would be 0. So only thing is, you will be finding what is the velocity at a different point. So that means you will be finding the kinetic energy, and the pressure energy is obtained from the piezometer. So the sum of the pressure energy and the kinetic energy at each and every locations, you are finding it. And finally you need to show that these values are almost same, right? But there will be some differences in these values. So that is because of the losses. Whenever as I said, the Bernoulli's theorem says that energy at different points are same, provided there is no addition and deletion. So here in this case there is no addition, because there will be some deletion because of the losses. So the losses are the losses due to friction, and other thing is because of the variation in the cross sections. So as there is a variation in the cross sections, right? So there is sudden expansion, sudden contraction, there will be additional losses, but so because of that you'll find there will be some difference between the energies at different cross sections. Otherwise, if the energy at the various points would be constant. Okay.